I will remind people that really jumped out to me, and this will tie into our next discussion, and that is that PFAS is very sticky and sticky to proteins. And so realize that, from the time that you were born, you have all the instruction to make all of your body, all your organs and so forth. And not only and you only get carbohydrates, proteins, and fats primarily to work with, but not only do you have to make all those structures, you have to make the workers that make those structures. And the workers are primarily from the protein class. And so, these are enzymes or receptors, so on and so forth. When there are chemicals that have a tendency to stick to proteins, there's a great ability to interfere with their functioning. So they can't move, they don't have the flexibility that they have because in order for them to do their job, they have to move. And so that's why this becomes very important. And it's not just PFAS also. So you have to look at in total other things, of which one of the other biggies is actually sugar, believe it or not, which can kind of do a very similar thing. So and I will also point out that, within our country, our health outcomes tend to be worse than almost any other developed nation. And there's some thinking that metabolically, only about 7% of the population may be metabolically healthy. So everybody else has some element of dysfunction, in which case part of our goal is, when we're looking for things, is to look for what is optimal and not just normal, because in our country, the abnormal has become so common as to appear normal. So we really want to go for optimizing our health. So with that being said, we're going to go to Dr. Petriello's discussion. His research is directly relevant to the understanding the mechanisms that link nutrition and toxicology and lead to translatable prevention strategies that limit pollutant-induced metabolic disorders such as diabetes, obesity, and cardiovascular disease, particularly in at-risk populations. He has substantial experience and interest in using large data sets to uncover novel associations of environmental risk and cardiovascular disease, as well as working with underserved communities that face multiple chemical and non-chemical stressors. Overall, Dr. Petriello's aims to investigate the biomarkers that link environmental exposures, diet, and metabolic diseases in human populations, and to test mechanisms of toxicity using mouse models in a cardiometabolic disease. So with that, I'm going to turn it over to Dr. Petriello. But before you start, I'm going to ask a question ahead of time, because I've seen some things to suggest that that PFAS may interact negatively with both dopamine and serotonin. And so if you have any information about that, I'd be interested, because dopamine is kind of our motivation hormone. And so if you find that you're having some difficulties kind of getting off the block, it could be because there's some impairment in your dopamine processing. And serotonin is the major transmitter that is responsible for us regulating our emotions. So if you find that your emotions are all over the place, there could be some environmental reasons for you having difficulty regulating your emotions. So if you have anything about that, I'd be particularly interested. So with that being said, Dr. Petriello, the floor is yours.
Thank you, Dr. Blessman. Can everybody see my slide here, full screen?
Yes, we can.
So it's great to be here. Thank you to Cures. Thanks to Rochelle and Carrie for inviting me. Great talk so far. So Dr. Blessman, your question about neurological relationships, that's the only thing I wasn't going to talk about. So I'm going to have a slide in a couple minutes talking about most reproducible effects of PFAS and what's known in human health. And they were ignoring the neurological side. Now, that doesn't mean it doesn't affect anything related to the brain and anxiety and depression. There's just much less out there. I will add this. So all of those hormones you talked about and transmitters are related to cholesterol, right? So they all have come from building blocks of cholesterol, testosterone, all of that. And I would definitely will talk about how PFAS can be related to cholesterol. So just a little bit about me. My name is Mike Petrillo. I'm originally from the Philadelphia area. Lived there through my whole life. Did undergraduate research in Pennsylvania. And then I moved to a rural area, Lexington, Kentucky, to get my PhD in toxicology. So there I learned a lot about interactions between nutrition and toxicology. And that's really what determines a disease risk, right? It's not just one exposure. It's not one lifestyle. It's not one genetic predisposition. It's kind of a cumulative mixture of all these things. And that's one thing that I took from Kentucky and I still focus on today. So I am an expert in molecular toxicology. So I determine how certain PFAS, how certain chemicals can actually elicit a disease. I focus primarily on cardiovascular diseases, cardiometabolic diseases, and that's what I'll talk about today. And just a little side point. So here's a picture of my family. This is at a park, our local park, right on the banks of St. Clair River, Lake St. Clair. And a couple weeks before this picture, I had my proud papa moment where I caught our first fish on Lake St. Clair, and my whole family ate that fish. So this idea of PFAS in our waters is really, really important to me and my whole family. Okay, so here is a figure from a review. So when I say a review, that means some expert scientist in the PFAS world did all the hard work for us. They went through all of the available literature through either Google Scholar or PubMed or any of these databases, and they picked out as many different papers they could related to PFAS and different disease outcomes. So that's important for us to think about, right? As whether we're scientists or the general public, we cannot make a strong case for or against something unless we look at the whole totality of the literature. I would not be a good scientist if I said PFAS caused kidney disease and there was only one paper out there related to kidney disease, and vice versa. If I was trying to say that PFAS doesn't cause a disease and I found one paper out there that showed no link, that would not make me a good scientist to say conclusively PFAS doesn't cause something. So I think we can take that strategy for PFAS, but a lot of other different things related to scientific literature. But what this figure does show is the authors went and looked at a lot of these chronic diseases, and they determined, was there a high certainty relationship to PFAS or a lower certainty relationship to PFAS? And unfortunately, Dr. Blessman, they don't have any pictures with the brain. So we'd have to find another review or another paper for that. But what I'd like to do today is go through these different bullet points and talk about the things that I work on, but also summarize the things that I'm not working on. So we'll just start at the top. So with liver and kidney dysfunction. So we all know that the liver is like our best friend and can metabolize a lot of different, whether they're byproducts of our own metabolism or xenobiotics, so things coming from the environment. What's interesting about PFAS is, yes, PFAS are found in our livers, but we don't have any metabolizing enzymes to actually break down PFAS. So we already heard the term forever chemicals with PFAS, and that was the environmental side. The half-lives of biological PFAS are actually very long as well. And a lot of it has to do with our livers cannot actually metabolize these things. Now, there's some evidence that there might be some metabolism related to bacteria, but much more work needs to be done to that. But at least our own bodies, we can't metabolize these things. So they get recirculated through our blood, through our bile, through our enterohepatic circulation. And that's another reason why we're exposed to these things throughout our whole lifetime. Now, with that said, so the PFAS definitely do get to the liver, and there's lots of evidence in humans and in rodents and in other models that it causes liver injury. So if you ever go to your doctor and you're looking at your ALT or AST levels, that's what we see associations with PFAS and liver injury. Same thing with the kidney. So a lot of the PFAS, we talked about 15,000 possible PFAS. A lot of them are excreted. We lose them through our urine. And so if it's going through the urine, it's going to impact the kidney, right? And there's a couple interesting things with the kidney. So there are human associations between the efficiency of the filtering of the kidney and PFAS. You may have heard of this clinical term, glomerular filtration rate, or EGFR or GFR. So there's associations with decreased filtration rate. And also this biomarker of kidney injury called uric acid. You might know uric acid related to gout in your feet. It's also a good biomarker of kidney function. So there are human associations with those two things. The interesting thing with the kidney, other than that we're excreting it, there's actually transporters in our kidney that can reuptake some of these PFAS. So if you know that, what is that reuptake impacting on things that normally should be reuptake? So there's a competitive kind of uptake of PFAS in the kidney, and maybe some important vitamins or nutrition or anything that might be actually advantageous to health. So moving down to reproductive problems. So there is strong evidence that there's associations between PFAS and male and female reproductive issues. So male, we have some ongoing studies and cures related to paternal health. So there's relationships with semen quality, sperm count. We have some really interesting work going on with the epigenetics of the sperm. So not just it's impacting the fertility of the father, but also maybe the predisposition of the offspring. So there's a lot more to come out with that. On the female side of things, there's significant associations in humans with endometriosis, for example. There have been some really large studies looking at fetal growth retardation, which I know is a really important thing in Detroit. Decreased fetal growth, but also preterm birth. So I currently have a grant to look at PFAS and preterm birth. And we're seeing that there's impacts of the PFAS at the maternal and fetal side of the placenta that might increase the risk of preterm birth. And it is well established that PFAS can cross the placenta. So there's lots of developmental possibilities as well. So moving down to developmental effects, there's not much out there related to teratology. So birth defects, that's the study of birth defects. There are some examples of in utero exposures related to adverse effects in the childhood, for example, but not nearly as much related to, say, issues with the brain development or hand development or cardiac development. There's some evidence in mice and other model systems, but more needs to be done in humans for developmental effects. Moving down to the immune system. Now, the immune system is one of the most reproducible effects that we see with PFAS. And in general, we see an immunosuppressant effect. So PFAS can actually decrease what the immune system is supposed to do. So there's a lot of evidence related to decreased response to vaccination, for example. We actually have a paper coming out looking at COVID antibodies after the COVID shot, and actually PFAS exposure decreases the response to the vaccine. There's a lot of evidence out there related to childhood asthma. So if anyone knows about asthma, it's definitely an allergic reaction, and the immune cells are very important for that. There is also a little bit of evidence related to the severity of infection. So if you go into the literature, you can actually find some evidence that increased PFAS can impact on SARS-CoV-2 the severity, as well as the flu. That grant that I talked about related to preterm birth, we're really especially interested in microbial-induced preterm birth. So about 40% of all preterm birth can be related to maternal infection. And we really think that PFAS can downregulate some normal protective mechanisms of the mom, and that can lead to a higher risk of preterm birth, say if she becomes in contact with a bacteria or a virus. Okay, tumors and cancer. So we do know that there are associations with some rare blood cancers, for example. A lot of that evidence is from high occupational exposures. There is not much evidence right now linking to breast cancer and some other cancer types, but this has been understudied compared to, say, the immune system or the metabolism that I'll talk about next. Um, Thyroid disease, I would say maybe top three most reproducible effects in humans. So for the most part, there's been links to hypothyroidism. So the thyroid is not working correctly. And there's lots of different possible mechanisms for this. If you've heard of the term endocrine disrupting chemicals, PFAS are classified as EDCs. So they can interact with proteins that normally bind the thyroid hormone. They can mess up feedback loops, like regulatory feedback loops. So maybe your body thinks that it has more than it does. And then there's also impacts on thyroid stimulating hormone. So a lot of these things you might get checked at your clinic with your primary care physician. Okay, going down to the two that I've focused on most, uh, metabolism and cardiovascular disease. So along with being EDCs, endocrine disrupting chemicals, PFAS are definitely metabolism disrupting chemicals as well. This is a newer term, but it's pretty obvious that these PFAS can impact a lot of different types of metabolic processes. We focus primarily on the cardiovascular side. So we're really interested in how PFAS can modulate lipids like cholesterol. And cholesterol is the most important and preventable risk factor for atherosclerosis and other cardiovascular diseases. So what we're seeing is in humans and in mice and in cells, PFAS is linked to higher cholesterol levels. And we think it's through impacts on mechanisms related to cholesterol recycling. So normally the body, we talked about this in the beginning, the body is really good at handling things when it's not in combat with another stressor like a PFAS. So cholesterol is normally recycled into these things called bile acids. But what we're showing is the PFAS can actually disrupt this normal physiology, leading to higher cholesterol and increased risk of cardiovascular incidents. So those are the big health outcomes that this review pointed to. Again, not to say that there's no neurological issues, but these are the endpoints that have been focused mostly so far. Okay, and so the last thing I want to talk about today is what can we do to decrease the risk? And this is what I get asked at Thanksgiving by all my aunts and uncles and everybody. What can we do? So we heard about the big thing. We need municipalities to actually decrease the exposure. We need manufacturers to phase these out. We need big legislative change. So with that said, there are things that we can possibly do at the individual level to also decrease our risk. At the individual level, we can throw out old Teflon plate pans, for example. So if you have an old pan from when you got married from Calphalon or whatever these companies are from your registry and they're scratched now, throw them in the garbage right now. I know I've kept my Calphalon pans way too long. So what do you do? What do you pick? So stainless steel is a good go-to. There's other different coatings, but if you have scratched pans, throw them out. If you have the means, you can incorporate a reverse osmosis water filtration system into your house. Super expensive. It's not something that I'm currently doing myself, but it is a possibility. But some things that we can all do. So when I was at Kentucky, I learned that we could buffer against the toxic effects of some of these chemicals. And whether that's through healthy nutrition or exercise, we know as toxicologists that PFAS impact on, say, your immune system or inflammation. a lot of these healthful lifestyles can actually buffer against a lot of those same mechanisms. So we're always trying to promote what can you do personally, whether it's increasing your fiber, which may have anti-inflammatory, but also may increase the excretion of PFAS. Maybe exercise can do the same things. It'll increase your buffering capacity against some of these toxic effects. Now, there's some other things that some folks are kind of promoting now that I currently haven't done myself, but I want you all to know about. So there's a lot of evidence that these PFAS can actually circulate in the blood a lot more than, say, stick in your fat compared to some old legacy compounds. So if you think about it, how can you possibly get some of these PFAS out? And that's to give blood. So you could go to your doctor when you're going to do your normal lipid panel and say, can you take an extra vial and just throw it away? That has been shown to actually decrease circulating levels of PFAS. The other thing to talk about are there are no FDA-approved drugs to decrease circulating PFAS, which is what we all want to identify as toxicologists. But there's some hints and some whispers out there that there may be some drugs that can do this. So we talked a little bit about bile acids and enterohepatic circulation and how the body cycles these things. Well, there are drugs out there that target the enterohepatic circulation. We're focused on a few related to bile acid resins and some transporters. So we have ongoing mouse studies, but there's even some very small clinical trials out there that have shown that these type of drugs are effective. So ways to go in all of this to figure out what is the best therapeutic for you, but I think it's important to think about. So with that, I think we're ready for questions, right?